When I started out as a young student, I began my scientific career with the study of physics, mechanical engineering, and computer science. After a few years, though, I switched my major to anthropology and archaeology and ended up becoming an anthropologist and archaeologist. For the last 10 years, however, I've been working in the field of sustainability and education for sustainable development. Now, I know that might seem like some big steps and changes, but I promise you there is some overlap and there is a common underlying theme which kept me going through all of these. And that's the concept of complex systems and systems thinking. I was always fascinated by complex systems and complex systems dynamics, which is why I started out in the field of physics. It's a good place to start when you want to learn about the mechanics and the basics behind these things. I started out looking for answers to the way things are, right? The status quo. The switch to archaeology and anthropology pretty much came from the question, how did we get here? Whereas sustainability tackles the questions of where we want to go. So let's talk a little bit about complexity. If you know the difference between complicated and complex systems, then you really are good. We can look at them linguistically. A complicated system, the word complicated comes from Latin. It has the Latin roots com, meaning together, and plicare, which means to fold. So that means a complicated system is one with many layers that are folded atop each other. And if you need to, or if you want to, you can take off individual layers. You can look at them, change them, and put them back. And if you're lucky, you still have a functioning complicated system. Now, complex systems are a little bit different. Again, looking at it linguistically, the word is also Latin, com together again. This time it's not plicare, but plectere, which means
to weave or to braid.
This means that complex systems are systems in which the individual elements or layers cannot easily be taken apart from one another. They can't even be analyzed well without influencing the others. I find this very insightful, and it's always a good place to start the conversation on complexity and sustainability. Complexity theory has its roots in early 20th century applied mathematics. And it states that complex systems are made up of many discrete subsystems which are in constant interaction with one another. And it's this interaction which leads to what are known as emergent phenomena. These higher level complex phenomena are very difficult to predict when analyzing and looking at only the subsystems themselves. I like to visualize this with a very, very simple game called Conway's Game of Life. The way it works is you have a grid of cells, and each of these cells represents an individual or a subsystem. These cells have two states. You can call it alive or dead. In my example, which you will see in a moment, the gray cells are dead and the yellow cells are alive. Now, the interaction between these cells is governed by a set of very, very simple rules. For a cell that's alive, each one with one or no neighbors dies as if by solitude. Each cell with 2 or 3 neighbors survives, and each cell with 4 or more neighbors dies as if by overcrowding or overpopulation. For the dead cells, each dead cell with 3 neighbors that are alive comes to life as if by birth.
As you can see, when I start with just 10 living cells in a horizontal line, the interaction between them and those around them results in a beautiful sustained pattern of birth and death, repeating infinitely and never returning to its initial state. If, however, we slow down the simulation and pause it, we can change some of the parameters. And when we do this, we see that even the slightest change can lead to some very drastic and unpredictable outcomes.
Since the 1980s, Natural scientists have been looking at the world in which we live more and more as a complex dynamic system. This gave rise to the field of Earth system science, which looks at the world as a complex whole made up of its individual subsystems or spheres. There's the atmosphere, there's the geosphere, the hydrosphere, the magnetosphere, and then there's the biosphere. And that, first and foremost, is where we come in. We, like all other animal and plant inhabitants of this planet, are an emergent result and an integral part of the biosphere of our world. And we can really see our place in it all in the great acceleration of the last few hundred years. We are in the midst of a very startling increase in activity, both on the social and on the global system scale. Many indicators of human activity, including population, water use, energy consumption, all demonstrate an exponentially increasing trend. Looking at indicators for the rest of the natural world's subsystems, we notice the same trend, be it in terms of atmospheric CO2, ocean acidification, tropical forest loss, loss of biodiversity, to name a few. And it's this last one that really gets to me. Now, I've worked on a few paleontological excavations, and I know that when defining a geological age, paleontologists look at the clustering of species in the fossil record. When you dig deeper, you find different groups of species, each group emerging from the interaction of the conditions in the Earth system at the time. Now, we've had a few mass extinctions in Earth's history, and studies are showing that we are in the midst of the next one, the sixth to be precise, judging by our extinction rates. Could we be at the end of our geological age? The Anthropocene, or Age of Humankind, is the name scientists are suggesting that we use for the time where we can detect on all levels and spheres of the planet the effects of human activity as the driving force of global change. This is why climate change and sustainability are such a big deal. The question, of course, arises, how do we tackle such a large and complex problem? Well, since it is a global issue and a global concern, we could look to the United Nations. In 2015, the United Nations came up with the 17 Sustainable Development Goals, or SDGs. Now, most have heard of the Paris Climate Agreement, and this is the overview of global goals set at that conference. Most commonly, people are aware of national commitments to reduce carbon emissions, but there are many other goals which really show the complex nature of the problem, and also the complex nature of the solutions that we need to find. So how do we measure sustainability? Well, we have a few tools at our disposal. Some measuring instruments. Most common are the ecological or carbon footprints. Then there's our water footprint, the ecological rucksack of our products. But there are some new approaches which focus not primarily on the negative effects of our behavior, but also on the positive ones. I like to use this slide to demonstrate what I mean. On the one side, you see a set of hominid footprints, 3.5 million years old, left in the sand. On the other, you see a painted cave from Argentina, dated to about 13,000 years ago, give or take. The difference between these two is subtle but profound. We can assume that the creature that left these footprints 3.5 million years ago in the sand in Tanzania did not do this intentionally. It was most likely on its way to forage for food. It was most likely on its way to search for a mate. It was most likely on its way to do something else entirely. And the footprints are just a byproduct of the behavior, a byproduct of the intention. Whereas the handprints in the Cueva de las Manos in Argentina were absolutely put there intentionally. The people who put them there wanted to leave their mark. This is why I personally prefer the approach of the ecological handprint. It's a measuring instrument, which is still in development, but it tries to tackle the complexity of sustainability from a positive angle, It tries to measure the positive effects that our intentional behavior can have on the Earth system. Whereas some of the unintentional effects of our ecological footprint are things like abject poverty and gender inequality and things like that. Some of the intentional effects of our positive behavior are things like habitat regeneration or emissions and pesticides reduction when we buy locally produced organic produce. So the question then becomes, what are we doing to leave our mark? How big is our ecological handprint? So as I said earlier, the idea is if the problem is complex, the nature of the solutions must be just as complex. And it's this idea of agency in complexity which I find very empowering. The idea of not being overwhelmed by the complexity of the problems of climate change, not being overwhelmed by the complexity of the problems of global injustice, by the problems of environmental degradation, but understanding that we, through our behaviors, are actively creating the system in which we live and are constantly and actively influencing it on levels which we can often barely imagine at the moment. This is what I find particularly empowering, and this is what motivates me for sustainability.